road, that is from circular motion chapter in physics, where it's given that what is the question. Just read out the question first. It's asked that what is the correct angle of banking for a curved road. That means banking of a curved road. It is asked into the question, and the radius of that curve is 150 meter, and speed of the four-wheeler vehicle is there, that is 100 kilometer per hour for a four-wheeler vehicle. Okay, so if you see the road, right, it is having some inclination. Okay, and with this inclination, with the horizontal plane, you can see there is a, this is the ground, right, but the road is not prepared over here. Okay, so some elevation is given to the road just so that car will not overturn. That means the normal reaction, to balance the normal reaction, these bankings were provided to the roads, right? So let's say this banking is theta, right? This is theta. Now this need to be calculated, and when you see the road is looking like this, right? Road is looking like this, and when you connect it, okay, and when you connect it, there will be a center for this entire circle. Okay, for this entire circle there will be a center. Okay, and this will be the radius of this banking. That means if your vehicle is standing over here, right, if your vehicle is standing over here into the center of the road, right, let's say here, this is your car, this is your car, so this car is running on the, this is your car, right? Now we need to understand how the different forces we are acting onto into this car, where the banking is given to you. So here you can see, so from this point, center point, to the center of this circle, where the circular path you are considering, let us say this is r, this is the radius of this circular path, right? Now the data given into the question, the car which is running on this circular track, right, which is running on this circular track, is having the velocity v of 100 kilometer per hour, right? This is the velocity given, and it's also given that the radius is 150 meter, right? And another data as given to you is the value of acceleration due to gravity, that is 9.8 meter per second square, right? Now we need to find the banking of this road. That means we need to find the value of this theta, this banking. This theta need to be calculated, right? So let us draw the free body diagram of this car standing over here, right? When you draw the free body diagram, you can see this road is inclined. Hi Antonio. Here you can see the normal reaction of this car will be acting like this. Tell me if it's not, if you are not satisfied. Normal reaction is always acting 90 degree to the surface or point of contact. So here the road is this one. Here you can see this is the road, right? Hello Antonio. So this is the normal reaction which is into the direction of 90 degree to the banked road, right? Let us say this is the normal reaction R. We'll see the derivation also here, right? So if this is the normal reaction, then we can see, and if this is theta, then let us draw a parallel line parallel to the ground. Then what you can see, this angle theta will be equal to this angle theta. That means both these angles are equal. If this is theta, theta plus this common part, let us say this common part, theta plus this part, right? And when we take this dash line and from here making a perpendicular like this, then you can see this common plus this one is making an angle of 90 degree. Angle is theta, being alternate angle, we can say this angle is also equal to theta, isn't it? This angle is also equal to theta. Are you able to understand or not? Let me know. I am saying that if this is the ground and with this ground the road is made like this, okay? So this is the banking of the road, right? So this is ground, this is solid surface, right? This is solid surface and this is road. This is road, right? Now the car is standing on this. Actually, it's not a standing. It's so here you can see the normal reaction is this one, right? And this is the banking of the road theta. Then being an alternate angle, we can say this angle is also equal to theta, right? So here we can see if this angle is theta, this angle is also equal to theta, right? And if this angle is theta, then theta plus this complete angle, theta plus this angle is equal to 90 degree, right? This angle is equal to 90 degree, right? Then you can see this portion is common. This portion is common, and then you can see a line is drawn parallel to the ground, and here this common portion plus this angle is also equal to 90 degree. That means if this angle is theta being alternate to the banking of the road, we can say this angle is also theta. Now we have almost solved the question. How? Let us see. Here the component of the normal reaction perpendicular to this ground perpendicular to this ground, right? It's r cos theta, isn't it? It's r cos theta, right? So r cos theta is the component normal to the ground. Then definitely the component parallel to the ground is this one, which is r sine theta, right? And this is equal to the force which is exerted on the car, that is the centrifugal force, that is mv square by r, right? This is equal to mv square by r, right? And if you draw this triangle, we can say if this is r sine theta, then this r sine theta is lying over here, right? Then you can say tan theta is r sine cos theta, right? So when you write tan theta, we can write it's r sine theta by r cos theta, right? So let us write it. Tan theta is equal to r sine theta by r cos theta, right? And what is the value of r sine theta? R sine theta is the horizontal force acting inward, and this is compensated by this mv square by r, the force exerted on this car due to movement into this circular motion. So the circular effects mv square by r is the centrifugal force. So in place of r sine theta, can't we write mv square by r, right? mv square by r, and into the denominator it's r cos theta. R cos theta is equal to the weight of this car acting downward, that is equal to mg, right? So we have written sin theta is equal to mv by r, right? Because this is the horizontal component which are equated. Horizontally, these are acting horizontally in the horizontal direction. R sine theta is equal to mv square by r. So that's why in place of r sine theta we placed mv square by r, right? And in place of r cos theta we can see r cos theta is equal to mg, right? R cos theta is equal to mg. Why? Because this is the component of forces acting vertically, and these are compensated. These are vertical and this is horizontal, right? Now in place of r cos theta we can write this one, what? mg. And in place of r sin theta we have already written mv square by r, right? So here write m into z. So here you can see m and m will be cancelled out, and we are left with tan theta equal to v square by rg. So tan theta is written as v square by rg. So for any four-wheeler, this is the derivation for the banking of road, right? For any road which is having a banking of theta, then tan theta will be equal to v square by rg for any four-wheeler, right? Similarly, it will happen to the two-wheeler also, but we can see that derivation that will follow some different steps, right? This theta will not be there, right? This theta will be there, but exactly this that will two-wheeler, so derivation will be something different, right? So tan theta equal to v square by rg. Now the value of v is known to you, the value of r is known to you, the value of g is known to you. Just put up this value, then you get the value of tan theta, and theta will be equal to tan inverse that value. So the value of v is how much? The value of V is 100 kilometer per hour. 100 kilometer, but all these are in meter. You can see meter. So convert this 100 into meter. This will multiply it with 1000 to get 1 kilometer. 100 kilometer into 1000 equal to 100 into 1000 meter, right? By hour is one in a 1 hour 60 minutes, and in 1 minute 60 seconds. So 60 into 60 will be coming into the denominator, and the unit will be second, and here the unit will be meter. So this will be the value of V square, right, by Rg. That means it will be multiplied with the denominator of V square. So the value of R is how much? 150. So just write it, 150 into G. What is the value of G? 9.8. It's meter. It's 9.8 meter per second square. So second square will be coming into the numerator. So here you can see this meter and this meter. 2 meters are there. So you can cut these 2 meters with this meter square, right? And this second square will cancel this second square, right? This will be cancelled, and we are left with what? We are left with this 0 0 will be cancelled by this 0 0 of denominator. Then we are with 1000 into 1000 into the numerator, balanced by with a, and into the denominator is 36. 36. So it will be 36 into 36, right? Because this is a square is applicable to the denominator also. Now we have in denominator left with 150 into 9.8. So just replace this decimal 9.8, and here we have another 0, 10 into the numerator. This 10 will be cancelled this 0. So we will be having 1000 from 4 is 250, and 49360, 4936, and 4250 100. So this will be having 250 into 250, right, divided by 9 into 9 into 15 into 98, right? So this will give you the value, and when you take tan inverse, of that value, you will get the value of theta, which is your banking, right? So this is the banking of the road which we have calculated, right? I hope you like the solution. If you find it useful, you can simply like and subscribe. Yes, I hope you understand how this question is solved. This car was there on the bank, that is a road which is in a circular path. Now this car is having an inclination with the ground, and this is shown from here, from the side view, this angle theta. This angle of inclination can be, when you draw this imaginary vertical horizontal line, you can see this theta will be equal to alternate angle black theta, this theta. And you can see this green angle, that is unknown angle, plus this theta marked in black will be equal to 90 degree, this one, right? Similarly, this unknown angle green angle plus this angle will be equal to 90 degree, this one, right? When you subtract this common angle green angle, then you will find this theta will be equal to this angle, which is equal to theta. Now this normal reaction R can be broken into its component R cos theta and R sin theta. R cos theta will be acting upward, and R sin theta will be acting inward towards the circle, right? So the R sin theta is the horizontal component acting towards plus x direction, and here mv square by r is the centrifugal force which is acting into the minus x direction. You can see. So both these forces are equated. So that's why I've written in the horizontal direction r sin theta equal to mv square by r. Similarly, the component of r acting vertically upward is r cos theta, and this is compensated by the weight of that car, that is m into g. So in the horizontal direction, r sin theta equal to mv square by r. So what we did, since tan theta, from here you can see tan theta is r sin theta by r cos theta. So that's why we can write in place of r sin theta mv square by r, and in the denominator r cos theta was there. So in place of r cos theta we can write mg. Here m will be cancelled out, and tan theta equal to v square by rg, which is our formula. Right? This is the formula which we have derived. Now, the value of v is known to you, that is 100 km per hour. The value of r is known to you, that is 150 meter. The value of g is known to you, that is 9.8 meter per second square. Right? So in this way, we have solved this question. If you find it useful, you can just like and subscribe. Thank you so much, students. Thank you so much for. But mind it, this velocity written in its unit is kilometer per hour. Convert it into meter per second, right? Because the other units are in meter and second. In this way, we get the value of theta, that is the banking of the given road. Thank you, students. Thank you so much for watching. Bye bye. Take care. Thank you.